Hey, Talpinialized Math Industry, and we are gonna calculate the average of an atom with its atomic mass. So, in the last math video, we have been taking a look at the periodic table, and we have been taking a look at the number of protons, the number of electrons, and the number of neutrons. But what we're going to do is use that knowledge to understand what the average is with the atomic mass. What else we learned about is sometimes elements are denoted by this kind of, how it shows you. The symbol right here stands for aluminum. The top number talks about the mass number. The bottom number talks about the number of protons, or the atomic number. To find the neutrons, we need to do 27 minus 13, and we'll be getting 14. 14 neutrons. The reason why I chose aluminum was because we had a robotics meet yesterday, and the robots that we used are actually made of aluminum. Just like this catapult we made for prototyping. And yeah, aluminum would have 14 neutrons.
Who else? Over on the blue side, 1695B, 1695B. We've got hand tiger's B, tailpin. Must be an inside joke. Wow!
Yeah!
That was a sweet one.
So, what we're gonna do is, we're gonna be using that knowledge to understand what the atomic mass is, and calculating the average of them when we gather different amount of atoms with different mass numbers. But the question is, why do atoms have different mass numbers? Well, if you take a look at the periodic table, let's look at aluminum because it's a metal that we used in our video. Okay, so here is aluminum right there. It says 26.981538. We're gonna round it to 27. But the reason why I said many different atoms that are the same elements might have different mass numbers is because that mass number right here on the periodic table of elements talks about, this is the average number for the mass number for all of the aluminum atoms in the universe that is discoverable. So basically, in the range where we understand and see the entire universe, the average of all the different aluminum atoms are this as the atomic mass. That is how much mass an average aluminum atom would have. But how do we calculate that? First, we have to understand that these different atoms may have different number of neutrons depending on how many neutrons there are and how many they can be balanced. We have to understand behind this periodic table the isotopes. So the question is, what is an isotope? Well, an isotope happens when there are different atoms of the same elements with different neutrons. Neutrons are the ones that are supposed to balance protons. Any other subatomic particle besides an electron would have the different number of neutrons be changed. You can never change a proton. If you change a proton, the entire element will change, which you don't want. So here's an example. Let's say right here is the nucleus of one atom, and right here is the nucleus of another atom. We are not going to say specific element, but we're going to say that there's one proton right here, and there are 2 neutrons. Now, on the other atom, we're gonna say that there's one proton again, but this time, some crazy evil scientist managed to put in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So basically, this is an atom with more neutrons than this one. Even though the number of neutrons is different, they're the same element because the number of protons determines the element. So an isotope happens when there are different atoms in the universe that have different number of protons. For example, for Vex Robotics, this was supposed to be our endgame mechanism. An endgame for Vex Robotics will give you points for each tile you can cover. So this is the first prototype we used. This one right here is the second prototype. This one launches 2 at the same time. These are 2 catapults. When this one is only 1. So technically, even though there are different designs, we still call them prototypes. This one launches 1, while this one launches 2. These 2 are known as catapults, but they launch different number of objects in the field. Different number of objects is basically the same thing as looking at different number of neutrons in an atom. Robotics is more interesting because sometimes in the engineering design process, you have to iterate and reiterate and edit the design and make it different. So isotopes, elements are the same thing. You have the same element, but different number of neutrons.
Game coming up very, very, very soon. Three, 2, 1, and...
If we understand that an element can have different number of neutrons and can still have its very own personality, then we're gonna understand what the average mass of different types of isotopes there are.